Hello, so today we are going to try to solve this longest mountain in an array. So the problem is that we have a contiguous subarray. We want to call any contiguous subarray B of A mountain if it has the following properties. The length of the subarray B is bigger or equal to 3, and we have only some I between 0 and the length of B, such that basically at some point it starts out increasing the subarray, and then it becomes decreasing until the end of that subarray. And B could be any subarray of A. So it's kind of a mountain. It increases and then decreases. And we want to return the longest one. Basically, the length would be the sum of the increasing parts and then the decreasing parts. Just the sum would be essentially. And if you don't find it, we want to return 0, right? Okay. So maybe let's just agree, just so that we can visualize something here. So something like this. Okay, so we have something like this. But you can imagine the array can be like this, and you could have multiple of them. So with this array, it starts out increasing from 1 till 4, and then starts decreasing. So we have 5 elements. For this one, it's 0, and then the follow-up question is, can we solve it in one pass? Which probably means that we can do 2 passes. So trying to think, what can I use here? So I know of a way to find shortest distance from okay, let's try here with an unknown, and then so the unknown here is longest mountain length, right? And the data we have is just the array itself, right? So maybe if so trying to think what data could help me, what information that if I had, I could solve this. So what if I had the length of the longest increasing subarray, right? So that would be 1, 4, 7, right? And then, yeah, that would be pretty much the longest one. And then I could do the longest decreasing, and that would be 7, 3, 2. And so if I had these two, can I merge them? So, and then, but then the problem would become like where to join both, right? So, okay, so let's try. Actually, we can. I'm thinking maybe we could join them by just doing. Since we would have two arrays, one for increasing and one for decreasing, let's call this one basically maybe up. Let's call this one maybe down, right? So this one is increasing, so going up. This one is decreasing, so going down. And then basically just at up I and down I at the same index, that's where they meet, right? So we are going to look for the value at this position and then just sum that up, right? So I need two passes, one for up, three actually, one for up, one for down, and then final pass. 3 passes, and then so for the first so I will need this one. I'm not sure what to initialize it with, but maybe let's just start with 0, right? And let's keep that range of, and let's start with n here. So n will start out with a, and so that will be this. Then let's do something similar for down. Here, just so this would be like this. And then from there, I could just go through the for up, right? So if ai is, so since I'm doing I plus 1, I will need to do here n minus 1. So if that's the case, then that means that f of I is equal, actually I want to start from 1 so I can do I minus 1. So this would be basically minus 1 plus 1, that's the length of the increasing subarray. And then we need to do something similar for down, but except for down, we are going to start from the right. So that would be a range of what could it be? So maybe range starting from n minus 1, right? And then we could go down, stop at 0, and go like that. And then we need to check if I want the last one to be smaller. I want the one at the right to be smaller, right, than the one at the left. So what I want is this here, right? Or maybe what I can do instead is that if I want to match the previous one, it would be just this. It's bigger. All right, okay. Now, do we have a problem here with I minus 1? Because this starts at -1, so the last one, but 0 won't have anything good, so this way we can stop at 1 and we can check 0. Yeah. Okay, and then I'll say down I, if that's the case, is going to be equal to down of I minus 1. Actually, it's going to be so I think what needs to happen here is I'm gonna do 2 here. That way I could do I plus 1, right? So the 1 needs to be smaller than the one on the right. And now I could do down I equal to down I plus 1. And that way, here I can do another pass and just take for I in range of n again. I would just take, so I would have res here, and res would be equal to the max of res, and then res would be here would be up I plus down I plus 1, and I need to do that only if both are positive, which means I do have both up and down, and they meet at that point. So if this is bigger than 0, in Python can be just that, because the positive value is true, and same thing for down. So here I need end actually, and I could just do that and then return result. So it looks like it works for that use case. Now let's try a couple of other ones. So we have this, can have an empty one, can have maybe 2, 3, 4, and then go down 2, 1, maybe 2, 0. Okay, let's try this. Okay, submit. Okay, cool. So that actually passes. Cool. So just looking for this idea was good, and the main thing was merging both. Yeah. Cool. Okay, so can we improve this solution a little bit more? I'm thinking we could do zip here for up and down, and then that would pair up both numbers, right? Because if I do kind of take just the Python here and then do maybe let's say up is, I don't know, I'm just gonna grab some random numbers, so 0, 1, 2, 3, 4, then maybe 2, 1, 0, right? And then down, let's say it starts out as 2, 1, 0, 1. So they have 3. Okay, let me just make this. So 3, 6, 7, 8. 3, 6, 7. We need one more number. So let's put 0 here. And so zip for both up and down, if I convert that to a list here, okay, that gives me all the numbers as pairs, right? So I could map, right, some function and if I do a list out of that, so that will give me the sum. But I think even better would be to just map, or maybe keep the list still, but here do lambda, right? We would get two things, x and y. So I'll just do x plus y plus 1. Missing 1 required. Yeah, you can't pass 2, I think. Yep. So once I do sum here, so maybe something like, instead of map, let's just do sum. Just x plus y plus 1 for, or maybe just to make this more, for u d in just in an iterator. This would be a lot simpler. So we'd have that zip, and this will give us the number. So this is what I need actually to write this double for loop here. But I need another additional thing, right? Because I need to do it only if u and d, right? Because I want only positive numbers, right? And then after that, I will need to take the max, right? So we're going to the max. And so just something like this should be enough. With that, we could just replace all of this, right? And just return this. Yeah, so there is a problem when it's empty, right? So when it's empty, I can just do 0, so I can get the 0 value. Yeah, this should be, let me just put a list around this. And let's put 2, 2 here. Okay, so that looks good. Okay, so that sounds like it works. Another optimization I think I could do here is, well, for up here, yeah, it's not an optimization. Like I could have a list and just add to it and just pick the last element and increase by 1, but I don't see really a good reason to do that. So I think this is fine. Cool.